Alrighty. In front of you, you have a packet that says Unit 3 Test Review, and I'd like for you to think of this as just a Unit 3 review. Tomorrow you're going to do some independent practice. It'll be on your own, on silence. It'll be a grade so that we can see how you have retained the information from Unit 3. But I don't want you to think of it as a test. We're not going to be using it as a test. It'll just be a daily grade, but we want you to do the very best that you can. So you should be on your laptop right now watching this video, and I want you to feel free to pause and rewind this video as much as you need to. You're going to be going at your pace. We do hope that you will finish this during class today, but you will have all the opportunities you need to if you miss something or you need an extra minute to finish multiplying or something like that, go ahead and pause the video and then just keep going when you're ready. So this is independent work for you, and then tomorrow you will have an assignment that will be a grade that you do all on your own. So this is 10 questions. Let's look at number 1. The table below shows the time it takes a prototype car to travel different distances. And a prototype is just like a sample. What is the constant rate of change in this situation in miles per hour? Excuse me. So we know that the constant rate of change, or K, is going to equal Y over X. And we practiced this quite a bit back when we did that multiple representations paper that had the tables and the graphs, and you had to find the constant and then you had to write an equation. We did this quite a bit. So since this is a proportional relationship, we can either look at the changes in Y and the changes in X, or we can just compare Y and X. So before I start, I want to go ahead and label my X column and my Y column. And we know that anyway because miles per hour would put miles on top anyway. So the first thing I need to look at are my units. Notice that our problem says miles per hour, but we're given miles and minutes. Uh-oh. That means that we need to do something here in order to make our table easier to use. So I see that I'm given 0 minutes, 12, 15, 30, 45 minutes. Now, how many minutes are in an hour? There's 60 minutes in an hour. So I'm going to put another row down here, and I'm going to put 60 minutes because this is 1 hour. And so what we need to figure out is, how many miles would I be able to go in 60 minutes, or 1 hour? So there are several ways that we can do this. I'm just going to show you one way. One way that we could do this is I could say, you know what? 30 minutes times 2 gives me 60 minutes. So I need to figure out what twice the miles would be. So 32 and 5/10. Let's add this time. Plus 32 and 5/10. Bring down your decimal point. Would be 65 miles in 1 hour. And so here I would say 65 miles over 60 minutes, or 1 hour. And that would be my answer, 65 miles per hour. There's another way that we could do this too. We could actually set up a proportion. We could say, okay, let's name our ratio. That's our first step. I'm going to do miles over hours. And then let's set up our proportion. So we start with line equals line. And I can use any one of these that I want to. Let's say Let's say I'm just going to use 13 miles and 12 minutes. And I want to know how many miles in 60 minutes. And then I could just cross multiply. 12 times x is 12x. Don't forget that equal sign. 13 times 60, I could multiply that out. And I could say, okay, 13 times 60, that's 0, 0, put an x, that's 18, and that's 7. So 780. And then I want x by itself, so I'm going to divide both sides by 12 and get x equals 780 divided by 12. Well, 12 won't go into 7, but it'll go into 78 6 times. 6 times 12 is 72. I get 6, bring down my 0. Again, you should be pausing this video so that you can do the math on your paper also. 12 goes into 65 times, and so I still get 65 miles per hour. Let's look at number 2. Tim's mom filled the gas tank in her SUV and spent $54 for 22.5 gallons of unleaded gasoline. What is the constant of proportionality in this situation? Well, the first thing that I need to look at is here where it says constant of proportionality. That means that I'm looking for the constant, which means that I'm looking for how does my price change based on the number of gallons. So all I'm doing here really is finding the unit rate. Now there are two ways to find the unit rate. We can set up a full proportion. So step 1, name our ratio. We're going to do dollars over gallons. Step 2, line equals line. Fill in what we know. Well, we know $54 for 22.5 gallons. And I want to know how much per gallon, so how much for 1 gallon. And then I could cross multiply and divide. 22.5 times x is 22.5x. 54 times 1, that's easy. That equals 54. And then divide both sides by whatever's in front of x. And I would get x equals, I'd like for you to do that division by yourself, so go ahead and pause the video. Okay, so you've already worked this out by yourself. I'm going to quickly just go through it here. I know that I need to move my decimal point. So I have 540 divided by 225. And I think that's going to go 2 times, because 2 times 225 is 450. And I get 90 left over. So we add a decimal and a 0 and keep going. And this will go 4 times. So x equals 2.4. In other words, $2.40 per gallon. The other way that you could have done this, instead of setting up a full proportion and solving, you could have come over here and just said $54 divided by 22.5. You need to move that decimal. So we still have 540 divided by 225. So we end up in the same place. It's up to you how you'd like to do it. And then you would just solve just like we did over here. Let's look at number 3. A suitcase went up in price by 5% to $90. So we want to know the original cost. Okay, well the first thing I'm thinking as I'm looking at this problem is that it has a percent in it. So it's probably going to use is over of equals percent over 100. So I can figure that out from the very beginning. Now, if I go ahead and set up my problem, I don't know what's going to go where. I'm a little confused, but I'm going to do line equals line 100 because this is a percent proportion. And at least now when I look at this, I'm thinking, okay, at least I know kind of the format I'm going to use, and I can just start plugging things in that make sense. So, if it went up in price by 5%, then I'm going to put my 5 right here. 5 over 100 is 5%. Now, it went up to $90. So this is a little bit different than what we've seen in the past when we were working on percent proportions. So it's a little bit more complicated, but we're smart. We can figure it out. Let's just analyze this problem. Okay, it went up in price 5% to $90, which means that this 5% is added on to the 100% of the original price. So that means that $90 is, so I'm going to put it in the is place, it is actually 105% of whatever the original cost is. So let me explain that again. Yes, it is possible to have more than 100%. We want to know the original cost, so that was the total originally. Now it's $90. Well, $90 is more than this original cost. 105% is more than 100%. So we know that we're setting it up accurately, in the right place and everything. But the reason it's 105% is because we're paying the 100% of the original cost plus the extra 5%. So let's go ahead and start solving. You already know how to solve. We just cross multiply. So 105x equals 90 with 2 zeros added on. You've got to have this equal sign. Make sure that your paper looks just like mine. I want to get x by itself by dividing both sides by 105. Cancel those out. And I get x equals something. Now, unfortunately, this isn't 100, so I can't just cross out the zeros. So I'm going to actually have to divide. Let's set it up, 9,000. Make sure that you're giving yourself plenty of space and that you're writing very neatly. Everything should be in nice, neat columns. So 105 does not go into 9 or 90. So I'm going to come over here and I'm going to think, maybe 105 goes into 900 6 times. So let's try that. 105 times 6. Well, nope, that's 630. So I've got quite a bit left to go to 900. So let's try 105 times 8. That's 840. Would another 105 fit? No, because I've only got 60 left to 900. So I'm going to use my 8. And I know, I just figured out that that's 840. Let's subtract. So I have 60 left over. Let's bring down our 0. How many times does 105 go into 600? Well, let's use what we had earlier. 105 times 6 is 630, so it won't go 6 times. It's not quite enough, but I bet it'll go 5 times. So let's do 105 times 5. And we get 525. We can go ahead and start subtracting. Okay, we need to add a decimal and a 0 and bring that down. Extend our line a little. 630 plus 105 would be 735. So instead of 6, I'm going to put a 7. 7 times 105, I already figured out, that's 630 plus 105, which is 735. And I have 15 left over. Let's add another 0 and bring it down. Well, 105 is only going to go into 150 one time. So I have 45 left over. But I'm looking at money, and it looks like this is going to be $85.71. So I don't need to keep going forever when I have money. So we check to see if our solution is reasonable. If it went up in price to $90, does it make sense that it would originally be $85.71? That makes sense to me because it went up just a little bit. And $85.71 is just a little bit less than $90. So if you missed any of this, go ahead and pause the video, catch up, make sure that you understand everything before you move on. All right, number 4. Ken was pricing different ingredients for a recipe he was planning to make for a dinner party. The store sold 4 different brands of the same type of product. What is the unit cost for each brand? So we have to fill in the table. We have to find the unit rate. Unit cost is just another word for unit rate for each brand. And then we need to write a statement comparing them. So just something that we notice, something intelligent that we notice. So I know that to find unit rate, I can either set up a proportion like we did over on number 2, I think. Yep. Or we can just divide. So if I want to know, it makes more sense for me to say cost per ounce than to say ounces per cost. That doesn't make any sense. So cost per ounce is what we're looking for. So for brand A, we need to do $3.92 divided by 8 ounces. So we'll do $3.92 divided by 8. We need to bring up our decimal point before we start. 8 does not go into 3. I know 8 times 5 is 40, so it'll go 4 times into 39, and I get 32. Let's drop that 7, bring down the 2, and 8 goes into 72. Let's see, I know 8 times 10 is 80, and if I subtract 8, I get 72, so that's 9. All right, so brand A is 49 cents per ounce. Now let's move on to brand B. Again, you're pausing the video so that you can catch up, so that you can do your division. If you need to go through the division with me, follow along with me. If you want to do it yourself and then check, then feel free to do that too. All right, $1.92 for 4.5 ounces. Well, I already know that I'm going to need to move those decimal points because I can't divide by a decimal. So now I've got 19.2 divided by 45. Bring up your decimal point. 45 does not go into 1 or 19. Okay, so 45, 90, 135, 180. I think that's all that will fit 4 times. So I'm going to subtract 180, and I get 12. So I'm going to add a 0. 45 goes into 120. Well, 45 times 2 is 90, and 45 times 3 is 135, so it'll only really fit 2 times. I subtract and get 30. So let's bring down another 0. Okay, so now I have 45, 90, 135, 180. If I add another 45, that would be 225. Another 45 would be 270, and that's all that's going to fit. So 1, 2, 3, 4, 5, 6 times. And that was 270. And I get 30 again, so I can tell that this is going to repeat. So let's look at how we round. That 6 tells the 2 to move up. So this is going to be 43 cents per ounce. Because we got to make sure that we're rounding either up or down if it's not even. I'm going to let you do C and D by yourself. So I'd like for you to pause the video right now, or in just a minute when I say go. You're going to pause the video, figure out C and D by yourself, and then come back and press play to figure out if you were right. And I'll be looking for the work for C and D over here to show that you tried on your own. So pause the video now and go. Okay, so now you're back. The cost for C is 49 cents per ounce, and the cost for D is 40 cents per ounce. So take just a minute and pause the video and write a statement about what you notice with these prices. What do you notice? Are any of them the same, or some of them lower or higher than others? I need a statement, which is a complete sentence. Somewhere you can do it way off to the side if you need to. And pause now. Okay, so now you're back and we're looking at number 5. At an opening of a new art gallery, the owner hired a caterer to serve light snacks. The owner created a budget for 150 people to attend the opening, with a per-person food cost of $3.75. If the number of guests attending the opening was 62% more than they expected, so not 150 people, it was more than that, then how much more would the amount budgeted for food increase? So this is a percent problem. So let's write is over of equals percent over 100. This is another one of those where it's a multi-step problem. We're going to take what you are really confident with, which is solving these percent proportions, and we're going to add some extra steps in there. So let's start with line equals line 100. And let's go ahead and analyze what we're trying to figure out. Well, I have 150 people, but it's going to be 62% more than that. And the question isn't asking what's the new cost of food, it's asking how much more would he be paying. So I only care about the 62% more. I'm not going to make it 162% because I just want to know what the difference is. He doesn't want to know what the original amount was. He wants to know how much extra is he paying. So 62%. And the extra people are going to be the part that we're talking about. So 150 people is the original total. Now we want to know what part am I adding. In other words, what is 62% of 150? So now we can cross multiply. And I get 100x equals, go ahead and do this on your paper, calculate out 150 times 62. Pause the video. Okay, you should have gotten 9,300. And then we're going to divide both sides by 100. Ooh, yes, I can cross out some zeros. And 93 divided by 1, that's 93. So basically, he's going to have 93 extra guests. But that's not quite what it's asking, is it? It wants to know how much more is he spending. So at $3.75 a person, we've got to figure out the extra money he's going to spend. So if you want to multiply this out first, go ahead, and then you can check, or you can multiply along with me. I'm going to put an X and get rid of the numbers I carried. It's 5, 7, 8, 4, and 3. And then I need to look over here. I have 2 digits behind the decimal in my problem, so I need 2 digits behind the decimal in my answer. So he's going to spend an extra $348.75. Number 6. In science class, Greg and Georgia were using a science probe attached to a laptop to measure the speed of a marble as it exits from a 4-foot-long ramp. To double-check the speed, they measured a section of the floor that was 15 5/10 feet in length and used a stopwatch to mark the time each marble took to travel that distance. Greg and Georgia discovered that it took 3 2/10 seconds for a marble to travel 15 5/10 feet. They used the formula R equals distance divided by time to determine their calculation, where distance, D, was measured in feet and time, T, was measured in seconds. What was the constant rate of change that the marble traveled in feet per second to the nearest hundredth? Well, the first thing I'm going to do is draw my DRT triangle, because that won't be given to you on tests or on STAR, but you can still draw it on there. So I'm going to write DRT, make sure everything's in the right place. Go ahead and draw your triangle if you have not already. And then I'm going to look at my problem and I'm going to go ahead and circle what I know. So I know that the distance is 15 5/10 feet. I know that the time is 3 2/10 seconds, and I know that it's asking me for the rate, the constant rate of change. So they've already given me the formula. If I didn't have the formula, if they just asked me to find the rate, then I would know that R equals d divided by t. And I'd be able to come up with the formula just using my triangle. So I'm going to go ahead and write my formula. Rate equals distance divided by time. And whenever I have a problem that involves a formula, the first thing I need to do is always to write the formula. So that's step one, write the formula. Step two is to fill in what I know. So I don't know rate, that's what we're solving for. I know that my distance is 15 and 5/10, and I know that my time is 3 and 2/10. So I'm dividing 15 and 5/10 by 3 and 2/10. Now I know that I can't divide by a decimal, so before I even set it up, I can go ahead and move this decimal point to the right in both numbers. And then I'm going to go ahead and divide. So 15 and 5/10 divided by, whoops, I just moved that decimal point and then I forgot that I'd moved it. Let's go ahead and set this up correctly. 155 divided by 32 now. So I'd like for you to go ahead and do your division, and then pause, and then do your division, and then push play and see if you have the right solution. So I've divided this out. I've gotten 4 and 843 thousandths because it says round to the nearest hundredth. So the nearest hundredth means that I need to divide out to the thousandths place. The 4 is what I want to round, so I look to the next number, and the 3 will either tell me to go up or stay the same. And since it's less than 5, that 3 tells me that the 4 stays the same. So my answer, go back over here to your equation, we're doing new step, new line, is 4 and 84 hundredths. And then I need units, so that's feet per second. And of course you can abbreviate feet per second if you'd like. Now notice that I've done some work over here. I've multiplied 32 times several things just to kind of see. Like here I thought 32 would go into 155 5 times, but I was wrong. So it only goes 4 times. And so I was able to kind of refer back to these as I multiplied, so that when I got to this one, I already knew it would fit 4 times into 140. So that's a good tool to use if you want to make your dividing easier. Number 7, look at the table below. Graph the relationship between the number of dogs and the number of paws. Well, the first thing I need to know is that this is all 4 quadrants. Here's my x-axis and here's my y-axis. So since all of these numbers are positive, I know that I'm not going to be using these 3 quadrants. I'm only going to be using quadrant 1. So my x-axis is going to be number of dogs, and my y-axis is going to be number of paws. Make sure that you label and then also number your axes. So the first thing I'm going to look at for dogs is, can I number by ones? Well, yes I can, because it only goes up to 6. So I'm going to say 1, 2, 3, 4, 5. And I'm just going to number. And then over here I cannot number by ones because it goes up to 24 and my graph will only has 11 lines. So I'm going to number by 4s. I'm going to look at my numbers and see what's going to be easiest for me. So 4s looks easy to me because everything's a multiple of 4. And then all I need to do is graph these points. So I'm going to go ahead and ask you to pause the video in just a second. Go ahead and graph your points and draw your line, and then unpause the video to check your solution. Okay, so I graphed 2, 8, 4, 16, and 6:24. I could have kept graphing, but these are the only points I was given. So notice that this is a proportional relationship because it's a straight line, and it goes through 0, 0. In other words, if I wanted to say how many paws for 0 dogs, obviously 0 dogs have 0 paws. Okay, they wouldn't have -2 paws or 1 paw or anything like that. So this would be a proportional relationship. Number 8, Susan rides her bicycle 7 miles in 2/5 of an hour. At this rate, how many miles could she ride in 2 hours? Well, I'm looking at this and I'm thinking, is this a DRT problem or is this a proportion problem? And I've decided that it's a proportion problem simply because it says at this rate. It also compares two things, miles and hours, and then I'm looking for one of those units in another situation. So because of that, I know that this is a proportion problem, or a problem that I could solve using a proportion. So step 1 is to name your ratio. So I'm going to name this miles over hours. Now the whole point of naming your ratio is that then we have to follow this for the rest of our problem. We can't just go being creative and mixing it up in the middle of the problem. You have to do miles over hours for the whole thing. So I'm going to start for step 2 with line equals line. This isn't a percent proportion problem, so I'm not going to put 100 down here. But I am going to start with line equals line. And then I'm going to fill in what I know. I'm given 7 miles in 2/5 of an hour. So 7. And then 2/5 can be a little bit tricky. 2/5 needs to be converted to a decimal. So if you don't know what that is, write 2.00 divided by 5 and go ahead and divide that out. So if I'm going to do that, I'm going to say, 5 goes into 20 4 times, and I get nothing left over, so 0.4. And then it says, at this rate, how many miles could she ride in 2 hours? Well, where's 2 going to go? Is it going to go on top with miles or on bottom with hours? 2 hours needs to go on bottom. So X will go right up here. I'm looking for the number of miles. So we're going to start by cross multiplying. This is 4/10 X equals 14. And now the next thing we need to do is divide both sides by 0.4. So those cancel out. And I'm left with X equals, this is step 3 by the way, and I know I can't divide by a decimal, so I need to go ahead and move my decimal point to the right, 1 space in both numbers. Let's do 140 divided by 4. Put your decimal in your answer. It doesn't go into 1. It goes 3 times into 14. That's 12. I get 2. 4 goes into 25 times. And no remainder. So X equals 35. But I can't leave this answer without a unit. So what's it asking for? How many miles? Remember, X was on top. That's where miles is. So all signs point to miles as my unit. And this answer is reasonable because 7 miles in 0.4 hours, so I should be able to ride more miles in 2 hours because 2 is significantly larger than 0.4. And 35 is significantly larger than 7 miles. Number 9. Sandra plans to run 16 laps around a track. Each lap is 400 yards. So far, Sandra has run 1,920 yards around the track. What percentage of the run has Sandra completed? Great, this is a percent proportion problem because it either tells me or asks for a percent. In this case, it's asking for the percent. So step 1, I'm going to go ahead and write line equals line 100. And then it says what percentage. Well, that means we're looking for the percent. So I'm going to go ahead and put my X right there. So now let's go back to our problem to see how to fill in the is and the of, or the part and the total. Sandra plans to run 16 laps around a track, and each lap is 400 yards. So let's go ahead and figure out how many yards she's going to run. 16 laps. Each lap is 400 yards. I need to multiply. So 400 times 16. I'm going to let you go ahead and do that multiplication. So pause the video, multiply, and then push play to check your solution. And I got 6,400. There are no digits after the decimal in my problem, so I put a decimal at the end. This is 6,400. Total, this is my total. This is how much she wants to run in all. And so far, she's run 1,920 yards. So I know that that's the part that she's completed. So 1,920 over 6,400. So we can go ahead and start cross-multiplying. So let's do step 2. This is going to be 6,400x equals, when I multiply by 100, I can just move the decimal to the left, or sorry, to the right 2 times. Or if it's a whole number, add 2 zeros. So 1920 is my number, and then I'm going to add 2 zeros for the 100. Let's divide both sides by 6,400. These look like really big numbers, but it's going to be really simple once we can get it all simplified. These cancel out, so I'm just left with x. And I can cross out some zeros here. Both of these numbers end in 2 zeros. So now I'm just left with 1,920 divided by 64. Always put your decimal in your quotient before you start dividing. And then again, I'm going to ask you to push pause, work out the problem, and then push play to check. So go ahead and pause now. Okay, so I'm left with x equals 30. It's not 3 because since I put my decimal in my quotient at the beginning, I knew that I needed to fill in a 0 here, even when I had no remainder. And go ahead and multiply that out. So always put that decimal in your quotient before you start. 30, and it's asking what percentage, so that's going to be 30% of my run. Number 10, look at the table below. What is the constant of proportionality? So remember that when I'm finding the constant of proportionality, or K, that means I'm going to do y divided by x. Y divided by x. And I can choose any one of these. Since it's a proportional relationship, any one of these is going to give me the same constant of proportionality. So I just want to use the easiest one I can think of. Well, I'm going to use my whole numbers. 3 over 5. And if I needed to turn this into a decimal, I would do 3.00, put my decimal in the quotient, divided by 5. And I know that 5 goes into 36 times. And I get 6/10 or 60/100 as my solution. So what I'd like for you to do, if you have some extra time in class before you need to go, then I'd like for you to go ahead and kind of rewind and rewatch the video for the sections that were confusing to you, or ask your teacher for some clarification if maybe my explanation in the video wasn't quite complete enough to help you understand, because we want to make sure that you understand exactly how to work any kind of problem like these. Tomorrow you're going to be doing some on your own to see kind of where you are and so that you can prove how much you've learned in Unit 3. Also remember that at any point you can go home, you can get to this video on YouTube like you have now, or you can get to it on hendeeholiday.com, clicking on assignments and going to the Unit 3 review. And we hope that you have that this video has been helpful to you. Please give me some feedback, and I hope you have a great rest of your day.